I'm a medical doctor by training, but also
to Pedro. Okay.
Yes. Thank you, Marie. Thank you. And I'm sorry, Hernani. I just want to say I'm sorry to Pedro because he asked me at what time does this finish, and I said, oh, around 5. I was very cocky, very convincing, and we completely shattered our initial estimation. So I'm sorry about that, and thank you for holding on and being.
There's no problem, of course.
Hernani.
So I just want to present. Now I have my computer back. So I just want to briefly thank Professor Pedro Campos. He holds the University of Porto and a degree in mathematics, and he is professor and analytics. Today he's going to talk about statistical and very interesting. Hear. So thank you, Professor.
So, was it only me? Did everyone? No, no one heard Hernani, right? Hernani is having problems. So Pedro,
oh, sorry.
Don't worry, Hernani. Don't worry. Let's just it happens. We all know this. So I'm gonna ask Pedro to introduce himself. Who better than Pedro to introduce himself? Thank you, Hernani. Thank you.
So thank you for that. I think I know my introduction by heart, so I'm not going to read anything, but just maybe to mention two of maybe my important jobs now. So I'm currently director of methodology at Statistics Portugal, so the national office, the national office for statistics, and I'm also professor at Faculty of Economics. So this building that you see behind me, it's real. It's not a picture, and well, I'm joking, of course. It's not so sunny like that today in Portugal, but so my links to literacy come from the field exactly here in Statistics Portugal, where I'm now, because we started to close the links, or to make the closer link between the official statistics and the users, so the producers and the users of statistics, and that's how it started. So I'm not a literacy expert, as I thought, as I saw in my presentation. So I think this is the first time that somebody calls me a literacy expert. So I'm more maybe a professor of statistics than a statistician. But anyway, so that's maybe my presentation. So may I start my screen now, Tiago?
Yes, please. You are in control right now.
Okay, thank you. So, the title of my presentation is something like "Seeing Behind the Data." So it's maybe a little bit ambitious, but that's my idea. So I'm going to use some of my some I would say important perspectives in terms of statistics and data mining and data science overall. So that I think that maybe these are the important points for you to see behind the data. So I'm going to start with it's data overwhelming, and then I will focus on the care that we need to take about the sources. I will proceed with the infodemic crisis, and data literacy. I'm going to focus a little bit on statistical literacy and the projects like data science for social good. And I will finish with, well, this is this is what I'm doing every day. So modeling and making statistics, simulating and experimenting. So I'm going to give you an example about that. So this is a point that everybody is aware of. Of course, we are overwhelmed of data. We are having data and more data every day. So there is a strong burden of data. And everybody knows about the big data. The big data has to do with this magic of the V's. The V's stand for volume, variety, veracity, velocity as well. And there are, I think, something like 10 different V's that we can associate with big data. So this is a huge problem nowadays. But of course, as we have seen previously here during this presentation, I'm learning a lot today. We need to take care about the sources. So so this is something that we need to do. And I'm having there are nowadays lots of fact-checking websites that you may need to see, like this one here. Maybe you know this one. This is about vaccines. Let me just click on that. So there is a news here because there are claims about the Pfizer COVID-19 vaccine ingredients that lack evidence. So this is what has been claimed. So the formation of non-neutralizing antibodies can lead to an exaggerated immune reaction, especially when the person is confronted with the real wild virus after vaccination. So this is the so-called antibody-dependent amplification that has long been known from experiments with corona vaccines in cats. And the verdict of this full fact checker website is that there is no evidence that antibody-dependent amplification, this ADE, is any issue in humans with COVID-19, and the use of plasma therapy suggests that it is not. So things like this can help us. I don't know if you have seen the other screen. Have you seen the other screen that I've shared? Because I'm sharing different screens.
Yes,
okay,
Pedro, we saw it.
Okay, so it's good to know that because I'm going to share other screens as well. So so this is one of the points that I'd like to share with you when we say that we need to take care about the sources. So take a look at these graphs. So these two different charts contain the same information, but with different visualizations. On your left, you can see that these are interest rates, and these are different interest rates according to the years. So it seems that these interest rates are increasing every year. But on your right-hand side, you can see that actually they are not increasing a lot. I don't know if you know why this is happening. Does anybody wants to comment on this graph?
That has to do with the scale that is used, right?
Yeah.
Not only the scale, but there is an interruption of the scale. That's right. That's right.
The second graph, we started 0% to counts, and another one, the first, we start on 3.1 or 14.
Yeah, that's right. Thank you. That's exactly that. So the difference has to do with the vertical axis, the y-axis, because on your right-hand side, it starts in 0, and in your left-hand side, it starts with a different value. So we can, in a certain way, change the way the graphic appears to the public. So this is one example where you need to take care about the sources. In this case, the sources, they are not crib data, they are not raw data, they are graphs. So this is already treated data. Another example, on the top, you can see the cumulative annual revenue of families, and you can see that the cumulative annual revenue is actually growing until 2014. But what's happening in reality is that it's not growing, is declining. So it's going down and down. So the annual revenue is different because you are computing on the graph below, the chart below. You can see that the annual revenue is going lower and lower. But of course, if you take a cumulative value, it seems to be increasing. So again, you have the same information, but if you consider different statistics, in this case, we are not considering a different scale or the origin of the scale, but the problem here is that you are computing completely different things here. One is the value itself, and the other one is the kind of a growth of the values. So we are living now in what we can call the infodemic crisis. So this is not my word. So I heard about this infodemic from the World Health Organization. They say that this COVID-19 outbreak and response has been accompanied by a massive infodemic. So what is an infodemic? Is so this is the definition, is an overabundance of information, some accurate and some not, that make it hard for the people to find trustworthy sources and reliable guidance when you need it. So only to take a view, maybe you know that already, in the first 30 days of the pandemic, there has been 361 million of videos that were uploaded to YouTube, in over 100,000 articles on this topic in Google Scholar, as well as 550 million tweets that included these terms here: coronavirus, corona space virus, or corona COVID-19, and so on and so forth. So we are indeed overwhelmed with information that provoke an erroneous public health response. And sometimes, you know, there are specific groups such as the chemical companies that falsely cure diseases. And you never know. It depends, of course, on the literacy of the public, to believe or not to believe in these sources. So, and of course, it may increase stigmatization and lead to non-compliance with public health measures by reducing its effectiveness. So what World Health Organization recommends is that everybody needs to identify evidence, avoid fake news, and support open science. So now I'm giving you some examples, maybe more from my side, from the quantitative one, data literacy, statistical literacy, that are, they are common in our fields. For instance, for statistical literacy, there is a group. I'm there also. I'm a deputy director in this group for some time. This is the International Statistical Literacy Project. We have a strong network in more than 80 countries. And the idea is to support the, capacity building, and also improve the statistic and promote statistical literacy in every part of the world. There are also numeracy, there is a numeracy group. In Portuguese, there is Alea from the National Statistical Office, and Exploristica, which is a physical exhibition and also a virtual one. If you just type exploristica.com, you will see something like that. This is more towards the secondary schools to play with data and to understand data. There is also the Center for Disease Control and Prevention, and they have health literacy. They argue that people need literacy and numeracy skills to find, understand, and use health information and services. Another very important project is this one, Statistics for Social Good from Stanford in the United States. They have some projects like this one. So these are volunteer-based projects. This one, for instance, is based on Denmark. And this is about global health, predicting patient cost loads. What is data literacy after all? So is this the same thing as statistical literacy or health literacy? So in general terms, we can say that data literacy is the ability to read, understand, create, and communicate data as information. So the idea is that we need to have different competences to deal with data, not only the statistical ones, but also the ones that are related to the context itself, like, for instance, health. There is another project also, civic statistics. This is, by the way, an Erasmus Plus project that finished 2 years ago. So the idea was to teach statistics based on disruptive, or let's call it like that, very, very social concern projects like malnutrition, environment, things like that. So, and based on that, we have defined the facets of statistical literacy. There are 3 main facets, like enabling processes, engagement and action and knowledge. And based on these different facets, you can develop the skills that you need to develop statistical literacy for civic statistics. There are also other projects. I'd like that you could pay some attention on this one here, data kind. This is a very important one. This is also a volunteer-based project for maybe more focusing on developing countries, harnessing the power of data science in the service of humanity. They also have different projects like this one here, data-driven insights into the state of the housing crisis across the United States with feature of property rights. And this one, exploring open data to support primary education in India. So if you want to offer yourself to help these guys here to promote statistical literacy, I'm sure that you are welcome. This is another one, data science for social good, that started in Chicago with Raid Ghani, a former senior advisor of the President Obama. And now it continues here in Portugal, by the way, in the Nova University in Lisbon. So they have this project. This is the Portuguese web page. So data science for social good is a non-profit, non-governmental organization that helps also non-governmental organizations and also governmental organizations harnessing the power of their data to improve its impact in the community. They have lots of different projects. I thought that I had an example here, but I have not. But you can just type data science for social good and you will see many examples where you can also offer yourself. Sometimes you can also get a job there if you find, if you want, of course, using this data science for social good as a very important connection. So now I'm going to change a little bit the focus to introduce the topic of data science. So this is my field of expertise, by the way, and data science, because I know that this topic today is about design thinking, and the students have been, the participants here have been touching different points, following a very systematic idea to develop their projects. Let me introduce something that maybe some of you also know, which is CRISP-DM. CRISP-DM is a very famous virtuous cycle, not a vicious one, that helps you developing projects in the field of data science. So the idea is that you start with the data. So in this case, you start in the most part of the cases with secondary sources, meaning that you are not collecting the data by yourselves. So this is not primary data in this sense. And then what you do, so this is data that you can find, for instance, in the hospitals or in the schools, at the universities, or in the mayor, in your city hall, and yet maybe about poor people, and that you want to make a marketing study, or you want to make develop something related to where you can use data science as a tool to get some insights about the problem. You always start with the business understanding. So the idea is that you start here, and the second stage is that you go to the data understanding. So you cannot proceed to the data understanding directly before accomplishing this goal of doing the business understanding stage. Then you do the data preparation, of course, the modeling. This is a very important point here in data science. Then you make the deployment, the evaluation, and then you go around and around in this virtuous cycle. So this is not new, of course. CRISP-DM is one of this methodology. Let me show you also the profile of a modern data scientist. In this case, this is a woman. We also have the same example with a man, but they are of course the same. So what you as a data science have to do to be in terms of skills. If you have maths and statistics, like machine learning and statistical modeling, this is important, but this is not enough, of course. Nowadays, you also have to have some skills in terms of programming and database. You don't need to be a programmer. You don't need to have strong skills in database, but I would guess that everybody now comes and graduates with some programming and database skills. Of course, that then when you get a job, of course that you will probably work with people with those skills. So in this sense, it does not mean that the data scientist has to aggregate all of those skills, but you have to work with people, like Thiago said in the beginning, in a networking point of view, in order to get those skills from the whole group. Another important set of skills are the domain knowledge and soft skills, something that we are, I think, pointing out today in this session today. So you have to be passionate about business. You have to be curious about data. You have to be a hacker mindset, or you have to have a hacker mindset, and so on and so on and so forth. And finally, which is a very, very important facet of a data scientist, is the skills related to communication and visualization. So this is not, I'm not the author of this, but these are the skills of the modern data scientist. And to proceed with that, some of you have already mentioned that before here today, the agile methodologies. These agile methodologies are nowadays very important to give a continuous link between your product and the customers. So you don't have to spend much of the time doing a perfect product. So the idea is to continue communicating and to satisfying your customer by using this kind of methodologies. And Scrum, for instance, is one of these agile methodologies that is used for developing, delivering, and sustaining complex products. So now let me give you an example of, for instance, how to explore COVID-19 data. So I took this from this website here. I hope that you can follow me with it. I don't know if you are able to see my spreadsheet. Okay,
yes,
so,
yes,
okay,
yes.
Thank you. So it contains a huge amount of data from, I would guess, all the countries in the world. So I think I have something like 18,000 rows, more than that, in this worksheet. And for each row corresponds to a country, the population in the country, and the weekly count of COVID-19 cases. And we also have the deadly ones, so the cumulative and the source. Okay, so what can I do with this data? Well, it's going to be very difficult because I need to restructure my worksheet in order to obtain something that I can deal with. As you maybe remember in that slide of the CRISP-DM, the different stages, there is one related to the business understanding. And I think that we can skip this one here because everybody knows about COVID-19. So maybe we could know something more about the source of this data. But anyway, it's important to know that we have the data here. And now let's proceed to the data understanding. So I have the data here, and I'm going to do something about the data. I'm going to turn it, like doing something very easy that I can do with Excel. So this is Excel. What have I done? I'm going to create a pivot table. And then with pivot table, I'm going to consider the country here. Where is the country? I'm going to consider the weekly count here. And year week. So the year week, it will help me to find a more comprehensive table. Now I only have one country in each different row on your left side. And then on the top, I've got the different years. So I have kind of a different time series. I don't know how many time series I have here, maybe the same amount as the number of countries that we have in the world. And well, but still, what can I do now with this data? It's very difficult. I only see numbers. Let me represent them by using a line chart like this one here. Okay, now I think I see something more, but it's very difficult because I'm used to see the, you know, the time in the horizontal axis. And what I have here in the horizontal axis are the countries. So let me just change the year with the country. That's it. So I think I'm trying to get there. But what can I see now? Well, I don't know if you can see this, but it's very difficult to interpret. But I think I see something like, this is the number of COVID-19 cases, and they seem to be growing very fast. Well, first you need to pay attention because this is only the data about 2020. So what we got here is the different different weeks that start in week number 1 until I think something like week number 50 something. So we even didn't reach the final of the year. So I think we are something like in the week 20, week 50 or something like that. So I'm going now to change because there are many countries here, and I'm going to select only some of the countries, like or something like maybe Africa. And why not Asia? Just the total of these 2 continents. And the picture now is a little bit more, I would say, optimistic. So it seems that at least in Asia, we have reached the peak in the week 39, which happened something like, I don't know, 1 month ago. And compared to Africa, Africa is slowing, coming, I don't know, maybe a little bit stationary, not going very up in the last few weeks. But now what I'm going to do, I'm going to add another country. Let me add, I don't know, for instance, okay, the United States. So what we can see now, well, now we can see that something is happening here. So the United States is increasing a lot. It has been increasing a lot in the past few weeks compared to what's happening in Asia, in Africa. So I'm calling your attention for this kind of analysis, because what we are doing here is we are playing in graphs and seeing different things according to the number of countries and to the type of countries that you are adding to this graph. So this is very important that you can use your knowledge, because you know, everybody knows something about COVID-19. And you know, of course, that Africa has been reporting less cases compared to Asia. And the United States is maybe the most big spot in the world in terms of deaths and the cases. So, of course, we need to take some care before analyzing this data and producing many different pictures according to what we want to do. So going back to my presentation, it was here. Let me now show you what is happening in Europe. So I'm going to show you a chart that shows the evolution of the weekly deaths in Europe. So what can you see here? So these are the weekly deaths in Europe, not only in 2020, but compared to the last 5 years. So we have 2020, 2019, 2018, 17, and 16. I don't know if you are being surprised with this information. That's true that we have a bigger peak in 2020 compared to the other ones, although this is not so big compared to what happened in 2017. The difference in the peak, it's only 10,000 cases compared to what happened in the beginning of 2017. But in the last few weeks, the number of cases of deaths, and we are taking all the deaths, not only COVID-19 deaths, are not so high compared to the other weekly deaths in the periods before. So let me continue because time is just reaching to the end. So of course, this is only exploratory data analysis, and data science has more complex tasks like classification, prediction, time series analysis, association, clustering, summarization. So what we have been doing here is summarization, but you have more important things, important tasks to do. There is a very important book that I invite you to try to read if you find it. It's from Foster Provost and Tom Fawcett. It's Data Science for Business. and I'd like to call your attention for this subtitle here, what you need to know about data mining and data analytic thinking. So this is the idea, is that you can think differently, systematically, following this design thinking, which is specific to data analytics. And this is a very good book that you can use to practice data science. If you want to know more about tools, so there is R, there is Python, sorry, there is a typo there, SQL, RapidMiner, and so on. So these are the top 2 or 3 in the world now. So to finish my presentation, I'd like to show you another way of doing data science, not with real data, but with experiments. So this is one of my fields of research, so doing simulation when we don't have the data. And I'm going to show you an example of how we can measure the network effects of vaccination, and if there is a good strategy for vaccination for COVID-19. So imagine that you have a network like this one here in front of you, where each spot represents a different person, like, you know, you have Kate Hawkins somewhere and Jessica Shearer here. So they are people that have other friends. But imagine now that they are, in the context of COVID-19, what we call the super spreaders, the people that can spread COVID-19, the disease, with more strength. So what we are using is a technique called agent-based modeling. So this is a simulation-based technique that uses agents, which in this case are people, are persons, are individuals, and also the relationships among them. And we combine all this, and also an environment, can be a city or a house or a hospital or whatever you want, that can be combined as a framework to study this kind of processes. So in this particular case, this model has been developed by 2 students from the faculty of economics, where I teach, and they belong to the master in analytics, and Barbara. So we have 5 types of agents. In the base model, this SIR model, we have the susceptibles, the infected, and the recovered, that we call immune here. But of course, we are not sure if the recovered people are also immune. I know that. And also we have added 2 different types of individuals, the smokers, or people that belongs to the particular risk group, and people that are deaf. So each one of them is assigned to a different color. And so I'm going to show you this model running here. So we have used a framework called NetLogo. So NetLogo is this one here. So you can just set up the model and run it like that. And you know who is the infected people. Okay, so these are overall statistics that you can, so I don't have time to show you, and I think this is going to be very different to talk about all these different parameters that you have in the model, like the population. You can just increase or decrease the number of the population that you have. For instance, in this case, I will multiply the number of population by 10 or something like that. I can also increase the number of smokers, people that belong to a different risk group, and also I can define the number of the initial people that are infected. But the important feature of this simulation is that I can consider the effect of a network. So in this case, for instance, if I set up, I can define networks between people. So based on a statistical social network analysis property of people, the average node degree, meaning the average number of people that who I am connected to, I can define this kind of thing. So let me decrease again, for the sake of simplicity, the number of population that I have here in this, like for 30 people. Let me set up this again. I'm sorry, something happened. Let me set up again. Okay, so some people are connected. So this is completely random. And what we have done is that now I'm going to run the model and I'm seeing what's happening. There is a peak here, which is higher than in the case where people were not connected by the ways of network. And what we are doing, this is not possible to see here, is that we have different strategies for vaccination. And one of the strategies is to vaccinate the super spreaders. I mean, the people that are connected with more people based on this average node degree. Another strategy is the one that we don't vaccinate this person, like a medical doctor, for instance, because he's connected with different people, or a professor, or I don't know, a health professional. But we vaccinate people that are around them to prevent the center of the network to be infected. And so I'm not going to show you the results, but we have the results that are simulated results that can help to find the best strategy for vaccination in COVID-19. So to finish my presentation, so these are the main takeaways. Don't forget the trustworthy sources, be aware of the methods and know the data and model, and you can also simulate and experiment. Thank you.